So, we'll start the presentation just right now. And maybe some people will come after. It's not a problem. So today we will speak about OpenIO and Zimbra. So Zimbra, I don't know if you know the product Zimbra. Zimbra, it's a messaging platform. It's a collaboration platform that allow you to use email contacts and calendars, and it provides the solutions for different kind of customers. I will show you that just after. So today we'll speak about that and the integration between Zimbra and OpenIO. Okay. So first I will present Beezim, talk about Zimbra, how the storage works with Zimbra, and how we integrate in OpenIO, and what are the benefits of the OpenIO integration. So, Beezim. We are a small company in France, and we exist since 2012. And we are experts in email and collaboration solutions. So Zimbra is one of the solutions we propose to our customers. We also work on Nextcloud and Collabor Online. So Nextcloud it's a Dropbox for on-premise deployment. It's like a product. It's a Dropbox-like product. And Collabor Online, it's a tools for online editing of files. So it's based on LibreOffice Online. It's a product that allows simultaneous edition of documents like Word document, Excel document. We want to do a maximum of innovation for our customers. So I will show you just after that we have several products and innovation that we propose to our customers. Integration, development, and we provide maintenance and training on all the products that we provide to our customers. We are Zimbra partner, gold partner, and now we are also a hosting partner. It's not displayed here, but we are a silver hosting partner. We work for different kind of customers, so private or not, university, and some ISP in France and outside France too. So most of the time it's a partnership with another company, and we do the we provide the expert resource for messaging and Zimbra. We have different products based on our developments that can ease the use of Zimbra and the integration in the infrastructure of the information system. So in all the products, I just want to show you just one here. It's the integration with object storage. So we developed object storage connectors for Zimbra, and one of the object connector is OpenIO, and I will speak about that today. We also have integration with other object storage. And two other products that we have that I want to show you particularly today. The first one is Beezim. It's a tool to do orchestration of migration. So we have the capability to orchestrate migration from one system to another, and to be sure that each migration task will end correctly, and roll back the migration if the migration fails. So this tool is also based on object storage for different parts of the system. And the other one is the integration of an external tool called Xivo. Xivo, it's an API for communication. So it's based on asterisk, and it allows communication on voice over IP, and and it enabled the integration in Zimbra, so you can have presence in Zimbra, click to call, etc. So, Zimbra. Zimbra is a very strong product. It's available since 2005, so it's quite old now. Old mean that there is a strong installed base of different deployment of Zimbra. And as I said, it can work for small business and for university, for ISP. It's very, very powerful. You can have a lot of features. The features you have in Zimbra is very complete, so it can compete with Exchange, Lotus, and any enterprise solution. You can extend Zimbra and on the UI, so you can add features in the UI, and you can add features in the backend too. And here we are working on the backend. So the backend storage of Zimbra, when you use it, at first it's based on storage on disk, directly on disk. I will explain that after. And now we can integrate in object storage like OpenIO. It's easily scalable. If you need more power, you just have to add more servers. And it can handle very large mailbox by design. The Zimbra roadmap, so in the future of Zimbra, there is a technical redesign of the architecture. And in the technical redesign of the architecture, we know that the product will need object storage. There is new API, new UI, etc. And now the product is ready for continuous integration and continuous deployment. And it will become a stateless product. That means that each component of the product will not remember any state or any information about the current user connected, etc. So it means that it will be very easily scalable after that. And it will be based on Kubernetes deployments that will allow to easily scale and add more nodes. So the Zimbra storage. Today, Zimbra storage is based on 3 different things. So the first one, it's the database. So the database will contain metadata of all the information that are stored in emails and contacts, appointments, etc. There is an index which is based on the product Lucene. So the index will have all the indexing information of emails, and it will allow the user to search in emails and to have answer immediately. And after that, we have all the emails. So all the emails, it's the major part of the storage. And we can separate the emails in 2 parts. The first part is the primary. It's emails that are less than 30 days. And the secondary part, it's for emails that are more than 30 days. We have 2 different storage for email because when we receive an email, most of the time the email will be, nearly most of the time the email will be deleted. And so the difference between legacy architecture and new architecture, with the legacy architecture, with disk storage, we use workaround for POSIX to store millions of files. So that means that we will have a directory, and we will limit the number of directory. So we will do hashing, and so there is not more than 4,000 emails on each directory to be able to work around the limitation of the file system, because the file system cannot handle a very large number of files. In the new architecture, we'll use centralized object storage. But the problem still remains. So in the new architecture, we will have to store millions of billions of emails. And you know that the emails are very small files. We noticed that it's on average size, and it depends of the usage that we have on emails, but on an average, we have 128 kilobytes of size. As I said, the half of the emails we received are removed in the first 30 days. And after that, the users want to keep archive forever. When they have the email in the mailbox and it's not spam, they want to keep it forever. And nobody wants to apply a strict quota policy. What I want to say with that is that it's always difficult to explain to users that you have to clean your mailbox because we don't have enough money to buy a disk to have more space to store emails. And as the emails are very important for them, they don't want to do that. So the solution for that can be to have bigger mailbox. So we come to integration with OpenIO. So the difference between the two architectures, so the legacy architecture with email storage attached to each server, and the new architecture with OpenIO, the difference is here. So here you will have all the emails stored in OpenIO, so in an OpenIO cluster. OpenIO will provide high availability and resilience for all the data, so for all the emails that are used by Zimbra. And as I said, we will have millions or billions of small emails, of small files to manage. And this is a pain for all the storage solutions that exist. I heard a presentation of someone from OVH last year that was speaking about Swift, and the text here say why storage of small files can be a problem with Swift. And they explain in the presentation how they work around with Swift to have more big object to store in Swift. So that means that they created something like a small file system to be able to concatenate files to store them in Swift object, to have less object to manage with Swift. So it's a problem that exists with Swift, and it's a problem that exists with, I think, any object storage solution. And of course, this impacts growing. So when you will add disk, we'll add new nodes, and it will impact rebalancing. When you remove a node or remove a disk, there is a balancing system, usually, in most of the object storage and software-defined storage, that will eat your IOPS and need a lot of performance. With OpenIO, when you add storage, there is no rebalance. When you add storage, there is no rebalance. That means that when you scale the storage, you add new nodes, the storage will be available immediately and can be used immediately. That's the big difference between OpenIO and another SDS storage, and I think any other SDS storage. That means that we don't have to rebalance before use the storage. And when we have a lot of small files, that means a lot of IOPS to rebalance, it makes a real difference. And the same happens when a node disappears. When you remove a node in the storage, there is no rebalance. So it makes a very, very big difference. With the OpenIO connector can handle primary storage and secondary storage. Before I explain what is primary storage and secondary storage, primary storage is for emails that are less than 30 days, and secondary storage are for emails older. The benefits, so we can easily scale the email storage. You've seen that as OpenIO don't rebuild the system, don't rebalance, the new storage can be available immediately. And usually what we see in production is that when you need more storage, you buy the new disk or new nodes just at the last moment. So you buy the node only when you absolutely need them. So with that, you will not have to wait 1 week or 2 weeks that the rebalance is done before using the storage correctly. And you will have nearly no impact on performance on the user side. So this is not a problem anymore. This decreases the number of dollars you will have to invest in your email storage, because you can have nodes that will be full. You can have nodes full of storage. It's not possible with other solutions that do rebalancing, because all the nodes will have a very important part of free storage to be able to handle the new object coming on the storage. So with that, with OpenIO, you can decrease the cost of the storage, and you can increase storage resilience. How you can do that? Simply because you will have less IOPS for rebalance, so you will decrease the time needed to recover the data. When something disappears in the cluster, to recover the data, to create a new copy, a new missing copy because the disk failed, it will require less time to do it with OpenIO, because you just have to create the new data and you will not have to rebalance. Okay. I will show you how it works with Zimbra. If I have access to internet. Okay. So, I've set up a demo platform with Zimbra, and the storage of this platform is done with OpenIO. It's not an OpenIO cluster. It's very simple. I used the Docker that OpenIO provides. So it's a Docker with everything in the Docker. And to be honest, the Docker is on the same host as the Zimbra server. So everything on the same host is just for the demo. Okay. And what I want to show you is that when you use the webmail, so we are using the webmail, and here we are reading an email. So I've clicked on an email here, and the email is displayed below. The email is read from the OpenIO storage. And as a user, when I read email like that, and I move around them, with a keyboard or mouse. There is no difference in the usage I do like this, and with OpenIO as a backend, and what I can do with classical disk storage. So the result is that we don't see any difference between a classical webmail with disk storage, Zimbra based on disk storage, and this one based on OpenIO storage. There is no difference, and that's the goal. So we can have, you can just replace this classical storage with OpenIO, and it don't make any difference. So the storage will handle all the emails. So one email will be one object in OpenIO, and it will handle also all the attachments you can create on the calendar, all the attachments in task, and this is briefcase, so you can store files. And this is read from directly from the storage, from the OpenIO storage. Okay. So it's very, very simple to see. And just to explain that maybe more concretely. So we have Docker running. So this Docker is simply OpenIO SDS. And of course, if I shut down the storage and I stop the access on the storage, here we will have an error message. Okay, so it's normal. I will not be able to read an email if I stop the storage, the OpenIO storage. So it's still possible to read some of the emails because there is a cache system that allows some emails to be available for user even if the backend storage is down. So if you have any question,